triangle congruencies, and we're going to start by talking about the different ways that we can prove two triangles are congruent to each other. We're going to start with side, angle, side, which is the first one, and then we're going to work through the others. And we're also going to talk about side, 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 or side, side, angle, and how we can't use that one, why we can't do that one. We're going to break these up into a couple different videos, so be looking for those other videos as we go. But we're going to start with side, angle, side. We're going to talk about that piece, and we're going to use that one. We're actually going to say this first one here is actually going to be our postulate, and these others are theorems. Okay? Now, what we mean by that is that we're going to assume the first one to be true, and then we're going to use that assumption to prove the others are true. Now, someone may be asking, why that one? Why do we assume that one to be true? Because it's the one I wanted to pick today. The truth is, we can actually pick, of these first four here, we can pick any four of these. We can do the same thing with this one, but it's a little bit limiting in our abilities. The first four here, we can pick any one of these first four as being the postulate, and we can use that one to prove the other three. The simple fact that we can do that actually tells us about the truthfulness, right, of that statement, that side, side, side. Now, what does side, side, side mean? What it means is that the side, the angle, and a second side in order, like if you're an ant crawling around here, and you go from one place to all the way around to another spot, and you can show a side of, say, 8 inches, 40 degrees, and 10 inches, because it wants to be a little bit longer, right? And you find this one's 8 inches, 40 degrees, and 10 inches as well. If those two scenarios are true, then these two triangles are congruent to each other, which means that A is congruent to D, C is congruent to F, and angle or line segment AC is congruent to line segment DF. Now, something I want to point out here as we go through this is if I were actually to measure this, I'd find that this length right here is roughly 7.5 inches. This one is, I did that the wrong way. This one is 14 inches, and this one is 11 inches. That backwards, pardon me. So what does that mean? What it means is that we're not necessarily looking at whether these objects are physically congruent. We're looking at this from a theoretical perspective. We're simply saying, under the assumption that these three pieces are congruent to these three pieces correspondingly, we have these two triangles congruent. We're not saying that they are actually measured and drawn to scale. It's a big thing in geometry, especially you put in geometry when we're dealing with things like this, is we don't just make the assumption that something is drawn to scale. We go by what the measurements are. So the thing that we'd start with here is the given. What's the given? The given are the things we assume to be true. So in this case, line segment AB is congruent to line segment DE. Angle B is congruent to angle E. And BC is congruent to EF. These three things, a side, an angle, and a side, these are our givens. These are things that we assume to be true. You may be wondering, how can we just do that? How can we just assume them to be true? Well, we do this in a lot of different worlds. It's not just mathematics. Some people push back and say, well, how can we just assume that to be true? Because we can. We have to start with a premise. On just about everything, we have to start with a premise. Like when we first discovered that Tylenol will relieve someone's headache. How was that discovered? Well, what happened is somebody ate a leaf and said, oh, look, my headache went away. There had to be the assumption first and foremost that that leaf would do something for them. So they tried it. They didn't know if it would work or not, but they had to try it. So ultimately, there was an assumption that was made in order for that to be true. And if you don't know what I'm talking about, go back and look up the history of Tylenol. The main drug in that is acetaminophen, which is a derivative of a plant. It's extracted from a leaf originally. It's made synthetically now most of the time. Anyway, so what can we do with this? Now that we have this, we can use this to prove the other things. Well, how so? Well, it really depends on how we set these different parts and pieces up. So if we wanted to use side, angle, side to prove angle, side, angle, we're going to need to construct this system in such a way that we can do that. Now, that's going to come in the next video, is these, where I actually prove a couple of these right here. But the idea is, how do I make this system right here prove one of these others, right? How can I push this together? Because right now, the idea is, well, if these three pieces are what I have, I'm assuming this to be true. What that means by postulate, side, angle, side, is that triangle ABC is congruent to triangle DEF, which means that angle C is now also congruent to angle F. That's what that means, right? So because remember, go back to the definition of congruent triangles. It means that all the corresponding sides of one triangle, or all the corresponding sides of these two triangles are congruent to each other. All the corresponding angles of these two triangles are congruent to each other. Not necessarily that F is congruent to A, but F is congruent to C because they correspond, right? But now we know that C is congruent to F. Well, if C is congruent to F, that means that we have angle, side, angle, right? So that means by this logic, and this is kind of a pseudo proof here of what we're dealing with. So that means that we have side right here, actually an angle, right? And we had an angle, we had a side there, and there's another angle. So there's, at this point, we now know that this one and this one are congruent. So now we have angle, side, angle, angle, side, angle. And notice how I'm marking this, by the way, too. I have one mark here and two marks here to designate those as being congruent to something, but not necessarily each other. Same thing down here. They could be the same length, but that's not necessarily the case. Same thing with the angles. I have the little curve mark and then one mark inside the curve. Same thing down here, except I have two marks. Designate these things as being congruent to something, but not necessarily each other. There's a corresponding piece to it. So there's a quick pseudo-proof to show there that angle, side, angle is a result of side, angle, side. Because side, angle, side tells us that if we have three pieces of a triangle congruent, then we know something else. Now, what we're actually going to do in the next video is we're actually going to start with this piece, and we're going to use that to prove this, okay? So one of the things I'm showing here is that this is a consequence of side, angle, side. The next thing we're actually going to do is prove that you can get to that you can use side, angle, side, starting with angle, side, angle. And to make a little bit more sense of the video. So watch this one, go watch the other one, and then come back and watch this one again maybe. It might be helpful. Okay, so once again, this is not a proof that we've done here. This is just kind of showing you that there's a consequence as a result of that. Okay, take care.